Have you ever wondered how a tiny baby, who can barely hold up its head, eventually becomes an adult who can debate philosophy or design a rocket? Well, a psychologist named Jean Piaget gave us one of the most incredible roadmaps for that journey. He totally changed how we think about, well, thinking. So, let's unlock the child's mind together.
So, here's a question. Are kids just tiny adults with empty brains? For the longest time, that's pretty much what everyone thought. That a child's mind was just a smaller, less filled version of our own. But Piaget had a hunch that something much more interesting was going on.
And this is where it all clicked for him. Piaget was working in an IQ test lab, but he wasn't interested in the right answers. He was fascinated by the wrong ones. He saw that a 4-year-old and an 8-year-old don't just know different amounts of stuff. No, their brains operate on completely different software. A kid's logic isn't just flawed adult logic, it's a whole different kind of logic.
Okay, so if a child's mind is so different, how does it build its understanding of the world from scratch? Piaget came up with a few core ideas that are basically the nuts and bolts of how we learn to learn. Let's get into them.
First up, we've got something called a schema. The easiest way to think about this is like having mental file folders in your brain. You have a folder for dog, a folder for how to eat with a spoon, a folder for what a ball does. They're the little packets of information we use to make sense of everything.
So what happens when you see something new? Well, first you try to cram it into a file folder you already have. This is called assimilation. Imagine a toddler has a schema for doggy. 4 legs, furry, has a tail. They see a cow for the first time and shout, "Doggy!" They're assimilating that cow into their existing doggy file folder.
But of course, a cow isn't a dog. It doesn't fit right. So what happens then? That's where accommodation comes in. This is when we have to adjust our file folders or sometimes create brand new ones. The toddler learns, oh wait, this big mooing thing is different. And boom, they create a new cow schema. That is where real learning happens.
This is just a perfect example. A baby is born with a sucking instinct. That's a built-in schema. You give them a pacifier and it fits that schema perfectly. Easy, that's assimilation. But then you introduce a bottle. The shape is different, the flow is different. The baby has to change their technique to accommodate this new object to get fed. It's this beautiful, constant dance between fitting new things into old ideas and changing our old ideas for new things that drives our growth.
Now, this whole process of building and changing our mental file folders isn't just chaos. Piaget believed it happens in a pretty predictable order, 4 distinct stages actually. Each one marks a complete revolution in how a child sees and interacts with their world. So Piaget laid out this incredible journey for us. We start at the sensory motor stage, move to the pre-operational, then the concrete operational, and finally the formal operational stage. Let's take a walk through each one.
All right, let's go all the way back to the beginning. From birth to about 2 years old, we're in the sensory motor stage. This is all about experiencing the world directly through senses and actions.
At this stage, thinking is doing. A baby learns about a rattle by shaking it, tasting it, throwing it. But the absolute game changer here is learning object permanence. That's the mind-blowing realization that when mom leaves the room, she hasn't just blinked out of existence. That's a huge cognitive leap. Okay, next up, from about 2 to 7 years old, we enter the pre-operational stage. This is the magical world of toddlers, where language and imagination just explode onto the scene.
Now, kids can use symbols. A banana can become a telephone. A cardboard box can become a spaceship. It's amazing, but their logic is still pretty wild, and they are profoundly egocentric, which means they literally can't understand that you don't see the world exactly the same way they do. If they're hiding by covering their eyes, they think you can't see them either. But then that egocentrism starts to fade, and a whole new kind of logic starts to boot up. This brings us to stage 3, the concrete operational stage, which is basically from age 7 to 11, your elementary school years. This is when a kid can finally understand that if you pour juice from a short, fat glass into a tall, skinny one, it's still the same amount of juice. They get it. They can think logically. But, and this is a big but, their logic is still tied to concrete, physical things they can see and touch. The abstract world is still just out of reach. And that brings us to the final mountain peak of Piaget's theory, the formal operational stage. This kicks in around adolescence and is supposed to carry us through the rest of our lives. This is where thinking gets, well, abstract. You can now think about things like justice, infinity, and morality. You can form a hypothesis, ask what if, and think through all the possibilities without having to physically test them.
It's the kind of thinking you need for higher math and deep philosophy. But here's the kicker. Piaget pointed out that not everyone actually gets here.
And that little note from Piaget leads to a fascinating reality check. His theory lays out this beautiful progression, but how many of us are actually operating at that highest level of abstract thought on a daily basis? Well, the answers are kind of shocking.
Take a look at this. This chart shows high school students, and you can see that even by the end of 12th grade, a pretty big chunk of them haven't fully mastered formal operational thinking. It's not like a light switch that just flips on at age 12. It's a slow climb.
And get this, when you look at the broader research, it suggests that only about 35% of high school graduates in industrialized nations consistently think at this level. Let that sink in. That means the majority of adults may not be using this type of abstract reasoning on a regular basis.
And what this all tells us is something really important. Our biology might get us ready for this kind of thinking, but it doesn't guarantee it. To really get to and stay in that formal operational stage, you need an environment that pushes you, that challenges you with education and problems that demand abstract thought.
So what's the big takeaway from all of this? What's Piaget's legacy? Honestly, it's hard to overstate it. He didn't just give us a cool theory, he completely changed how we teach our kids.
See, Piaget's big idea was that kids aren't just empty vessels waiting for us to pour knowledge into them. No way. They are active builders, constructors of their own knowledge. This idea created a revolution in the classroom. It's why we now see teachers as facilitators, not just lecturers. It's why kids use hands-on materials, work in groups, and solve problems for themselves. That's all Piaget. And that leaves us with one last big thought to chew on. Piaget showed us that how we think isn't set in stone. It grows, it evolves, it becomes more and more complex as we interact with the world. And it makes you wonder, what new stages of understanding are still out there for us? Not just as we grow up, but for the rest of our lives. What's the next level for our own minds?